Good morning, everybody. Good evening, good day, depending on where you're at. Um, it's another live stream of me sharing my thoughts, expertise in technology around DevOps, cloud, coding. It's a pretty wide range of interests, so who knows what we're going to get. A friend of mine kind of watched a couple of my previous streams and said, it's great and all you do is talk all the time. Why don't we actually do something? So I thought we would do that today. We're going to build or start kind of the early steps in a project for something I helped a friend of mine design a while back. So we'll kind of go through some of the early requirements. We will look at some possible architectural decisions and then see if we can make a diagram for it and maybe lay out some tasks that you might assign to your engineers or other people in your tech org. So that said, I think we should get started. So the thing that we designed was a ingestion engine. So this thing would take records from an upstream connection and do some analysis on it based on the previous values and then write them into some longer term storage. So we'll get into the various pieces, but as he was describing this, I thought this would be great for serverless. And I know, serverless is somebody else's servers. I don't want to get into that. I think serverless is a really misleading term, but it also is the most popular phrase. Functions as a service aren't. It's not. It just didn't pick up. FAS or whatever however you want to pronounce it. It just didn't. It didn't catch the attention the way serverless did. So we're going to call it serverless, even though we know it's not. So let's go through some requirements. First of all, I've created a project in GitLab. I've got the link over here if anybody wants to look at it. I plan on having this be public. People can download this if they need to reference the CloudFormation or maybe some of the code we're putting in here. So I set up a project in GitLab. In GitLab. Every single project I make will start with a Docker file, which currently is empty. It'll start with a make file and a README. I do this because I found this to be the most effective way to communicate with myself in the future. Where, what are the important functions? What are the important actions to take on this repo? So that make file will have, how do we build? How do we test? How do we ultimately deploy? I'll put those in there in the very beginning for local testing, local iteration. And then we'll hook up a CI/CD pipeline to it so that we don't have to rely on doing these things locally all the time. I ship a Docker file with all of my projects. Depending on what kind of project it is, there might be one Docker file, there might be multiples. It really depends. But I always ship a Docker file with it because I don't like doing a lot of configuration on my local machine. I don't like doing a lot of customization there because I've just had a lot of problems with machines specifically in a workplace environment. I've had a lot of issues trying to keep your local environment clean and functional. Python in the past is notoriously broken for me, hardcore. Full reinstalls, digging into the package manager, learning these esoteric commands from deep within, pip or whatever. So, I like to put it all in a Docker file and keep my local machine relatively clean. I've also found that it helps me recover very quickly after I, have a machine crash. It served me pretty well in the past, and I've never really been one to build a bunch of customizations or other tweaks or hacks into my local environment. I've spent way too many years hopping onto remote machines to rely on custom bash scripts or just a lot of the things that you see people do. You'll see a lot of people out there advocating for all of these things, but when you have an environment that you can't heavily customize, I don't want to get into that practice of relying on those things. Former coworker of mine, I'm not going to throw him under the bus, but he famously made a big deal about installing HTOP on all of our servers so that he could have a nicer output when he was jumping on them and trying to figure out what the heck was going on. So whenever a new machine would be having troubles, he'd want to get in there. First thing he'd want to do is install HTOP, even though there's plenty of tools already available on your system to troubleshoot. It ended up being a pretty we'll call it a vigorous debate. He got flamed pretty hard for it once he got into the group. Anyway, so yeah, Docker file. I love shipping a Docker file with my project. It allows anyone else who wants to work with this to pull that, to build the environment in that Docker file, and then be able to execute the same commands that I wrote with a very high degree of certainty that they're all going to operate the same way. I hear from a lot of friends of mine. Personally, I'm not a Java developer, but I've heard from a lot of friends of mine who are Java developers that sometimes setting up a project the first time can be very challenging. And really, that's any project. It can be really difficult to get that project off the ground if there's a lot of customization, a lot of modules to install, a lot of plugins. These things can really make it hard to get going on a project in the beginning. I find that Docker just simplifies a lot of that and allows people to get going fast. So Docker file for the environment, Makefile to communicate the commands with, and I do most of this for myself because my brain is an Etch-a-Sketch. I work on a lot of projects. I have to hop into a lot of different things at work, so I need to be able to quickly figure out what the heck's going on and then move fast and troubleshoot things. So I like to use the Makefile as my placeholder, the way that I communicate with people. What are the important commands you need to know for this project? And then the README. If you don't put READMEs in your projects, start. They're super important. I'm still looking for a good format for a README. I know some of you out there have strong opinions and good recommendations. So maybe I'll have to do some research and finally buckle down on a format that works really well. One thing I like to use the README for is to actually document the requirements for a project. That really helps me stay rooted in what the heck I'm building. And then it ships with the code base, with the repo, so that there's not... most places you go, you're going to find, you'll have Jira tickets that define the work that you're going to do, and then you'll have Confluence docs. Assuming you have an Atlassian stack in your company, all the information is spread out everywhere, and I hate that. Confluence is notorious for very quickly becoming unwieldy and impossible to use. So people stop using it. But the README, the README might be a great place to store a lot of that information. I think it is anyway. So, what are we going to create? So this friend of mine needed to take records from a WebSocket connection and bring them in, do some analysis on each individual record, and then output those analyzed records into some database for future analysis. And he wants to do, I think it was like 600. Let me check here, actually. I think I have the conversation still pulled up. It was between, it was like 6,000 of these records per minute. Which, depending on how heavy the analysis is, that could be some significant infrastructure that you need to operate to maintain that throughput. But for me, that sounded like a perfect use case for Lambda, inside AWS. I think it scales really well, especially if all of your operations are completely atomic and not related to each other at all. That really helps. You can set your concurrency on a Lambda really high. If you exceed the defaults of your account, you can put in service or requests into AWS, and they'll generally increase your default limits on your accounts. If you're learning AWS, learn where the limits are. Nearly everything you have in an account has a limit. API limits, you have resource limits. Each resource has limits down inside of it. So if you're talking about, load balancers or everything has limits. So whenever you're thinking about using a resource, remember that, learn what the limits are so that you don't find yourself hitting these almost artificial, ceilings in your performance. So anticipate those a little bit. We're talking about Lambda. So Lambda has a default concurrency across your entire account of 1,000 invocations of any functions. That's the top end of your default configuration. So if he needs to do 6,000 every minute, we're probably going to bump up against that depending on how long it takes. So that you'd want to put in a ticket with AWS support and try and get that bumped up. So let's start with some requirements. Let's see. So he's got an external WebSocket that he connects to. And then whatever connects to it receives batches of data every minute. So they're using some kind of data stream publisher. I've just recently been getting into WebSockets with a personal project of mine, and I think they're pretty fascinating. I really want to learn more about building out, front end applications using WebSockets. There's I think the browser behavior, like if you're building in React or Angular or Vue for your front end framework, the behavior of JavaScript callbacks and event systems actually kind of mirror the way it works. Your venting works in AWS. So I think building a front end application that has the same concepts of asynchronous operations as your back end does, I think there's a lot of power in that kind of conceptual framework. I've been very slowly getting into building front end applications on top of WebSockets in this limited free time that I have. I think that is, the future of front end design, or whatever, however you want to say it. But I think there's a lot of power in that. So I think new projects that I roll out that have a UI will probably lean into that. And WebSockets are super efficient. If you don't use a WebSocket, you generally have to write some kind of polling mechanism or something in your front end application. So it'll be, if you have a REST endpoint, I submit data, and then I have to poll on a timer to keep hitting that endpoint until the data processing is finished, and then read those records back in. It's terribly inefficient, and I really hate it. The WebSockets allow the server to push data down, so you can bring your event-driven architecture on the back end. You can bring those events straight into the browser without having to have anything on that end checking for data. Super powerful. I want to get into more, but for this project, we're going to ignore that in the beginning, because I couldn't find a really good AWS solution for this part of his build. I settled on a Fargate container that opens up the WebSocket connection and then writes records onto a queue. So the next step will be an SQS queue. Is that redundant? SQS Is that like ATM machine? I don't know. So there'll be a queue that receives all of those records. Probably, let's put this here. Probably a Fargate container. So that container will, be running, connect to the WebSocket. Every batch of records, it'll write into the queue. Each record individually, whatever it receives from the upstream will be written as an individual message on that queue. The next thing would be a Lambda function. It's triggered by that queue. So the queue will, as it receives messages, there will be a trigger on it. Or I guess the trigger's on the function. I don't know. I don't know where it lives. So those will create the events that then invoke the Lambda function. And when you build that trigger, there's a lot of ways to tune and tweak the invocation profile so that you can deliver a single message, you can deliver multiple messages. There's a lot of options for how you want to handle batches of records. If if each record itself is really, maybe each one is sensitive and you want to make sure that you don't have any uncaught failures or anything, you could do a record individually and then just have multiple invocations of your function. If that's less of a concern, it's generally a good idea to batch your records into larger payloads that you send to that function. So your function will generally have a loop at the beginning that iterates over the records in your event, and then handles them, however you decide. So the next thing we needed was a Dynamo to store the processed records, because in this app that he's building, the previous processed records become the data set that inform the new records coming in. So it analyzes trends. I don't know if it's maybe it's some kind of sensor, temperature control system, or some kind of sensor system that just gets an overwhelming amount of data, and then they need to make decisions on that. Maybe a temperature is trending high or low or something. I don't know. He didn't get into the details, and it frankly doesn't really matter at this stage. So we'll have a Dynamo table that this function writes the analyzed records into. When we first started talking about this, I didn't understand the data relationship very well, and as I was asking questions, it came out, kind of how we were going to build this. But the first thing, the initial design I kind of came up with was to have this container, the WebSocket consumer, write straight to Dynamo, and then use the Dynamo stream on the back end to trigger the lambdas. I really like that design pattern because there's even more configuration options in that stream. You can batch more thoroughly on failures. You can split your batch. There's just a lot of features and stuff in there for handling the flow. So I thought that was really cool. And once we started talking through the design and I asked more questions, then I realized that we didn't need to store the raw data coming from this. We just needed to store the analyzed data. So move the Dynamo table to the back, put a queue in the middle, and this is the real core of this kind of processing engine. The one thing that he did want was a way to do longer term analysis and reporting. So I thought, we could push those records to S3 for really long-term storage and really cheap storage, and then use something like Athena, or if you need really fast reports, you could use something like Redshift to take those records and do more ad hoc reporting on top of. So let's put that in here. We got an S3 bucket. So how you get to the S3 bucket here is kind of interesting. You could have this Lambda function that does your data analysis. You could have it write to Dynamo and then to S3. That could be, it would be really simple code to write. It wouldn't be that really that difficult. Another option would be to take your records from Dynamo, put a stream on this table, and every time you write one of these new data elements into Dynamo, have a stream on the back end that also basically subsists it down to S3. So, you know, it really comes down to, like, you know, how comfortable you or your org is with serverless and with distributed systems. And depending on how much, you know, what your AWS budget is too, honestly. Lambda functions, you pay per use. So you pay for every invocation, and then you pay for the time it takes to process. Splitting out the Dynamo, adding a stream onto the back end of Dynamo it would effectively double your Lambda invocations, because streams have two targets. You can either send them to a Lambda, or I think you can send them to SNS, which then, you know, needs to get processed. Oh, let's see. Let's just check this real quick. I dug into this before, and then I believe my good friend Benny out there corrected me last time. Yeah, looks like targets. Where do we get to go for targets? Bring this down here. I spend so much time in these developer guides on AWS. It's a good thing that these things aren't pay per use, because I would I would be poor man. Oh, that's right. So you can stream to a Lambda trigger, or you can go to Kinesis, it looks like. Kinesis is cool. I don't know. I think that's pretty overkill for what we're building here. So let's go back to here. So one reason you might want to use streams for your Dynamo table to basically back up your data to S3 is to keep the actual processing time down here in this Lambda, because that's going to be kind of, I wouldn't say a bottleneck, because this thing can scale out pretty wide, but you may want to keep this, you know, for purposes of you know, narrow scope for your functions. Maybe you just want this thing to do the analysis and then just rip through those records as fast as it can. This function actually is also going to be looking up records from Dynamo. So what I you know, learned while digging into this one is, so this function will receive an event from the queue, or a message from the queue. It'll look up all the previous events for that, you know, whatever ID or whatever is coming in from that WebSocket. So this function needs a bunch of permissions on Dynamo to read and to write. Maybe you want to keep the scope of the permissions of this function narrow. No, it's not a bad idea. Least privilege is a really good practice. It's sometimes really challenging to understand kind of where the boundaries are. But, you know, maybe there's a lot of maybes in this decision. But I like keeping them separate for the most part. So why don't we engineer this? Let's put a stream to Lambda, and then we got this S3 bucket on the back end here. So this isn't really a requirements doc. This is a This would be an architecture. Actual requirements. So we have 6,000 incoming messages per minute. Side note, you know, it might be tempting to say to reduce this down. You know, my daughter's going through, is currently doing the distance learning with the you know, the COVID-19 situation we have, and I'm helping her do a lot of fraction reduction. So this, you know, this would be tempting to convert down to 100 per second, right? Those would be 100 messages coming in every second. I like keeping it on a minute because a minute is the smallest granularity you can come up with, you can base a cron job on. So a lot of people out there who've been in the computer industry for a while, you know, cron becomes the way that they trigger things, and 1 minute is the smallest interval you can program into an actual cron statement. So by thinking of these in per second metrics, it might be more accurate. It might be more, might be better for your costing and understanding kind of that aspect of the design. But I like to talk about them usually per minute is as small as I like to go for rates or anything, just so that we can kind of keep the focus down in common units that people are used to working in. So I don't think when we're talking about rates that, you know, you might see, like, if you scroll through the AWS forums or Slack channels, or, you know, those various places where people are asking for design help, you'll see, oh, this thing needs to handle X per month or per day, or, you know, some longer term metric. And those things just don't, they don't hit to the actual usage pattern that you're going to end up supporting. If you get 100,000 requests per day, that's not going to be evenly distributed if it's human beings. You know, if this is a website and you get 100,000 hits per day, likely those hits are going to land on a bell curve by time of day, right? You know, you're going to have very little to zero traffic overnight. You'll have maybe a peak of traffic in the early morning, or, you know, 9 a.m. area, just because people are getting up. Maybe they're hitting, you know, if it's a social media site or super popular blog or whatever you have going on. The traffic patterns, you know, maybe you have a bell curve to your traffic patterns. Maybe you have, you know, a couple peaks throughout your day. Uh-oh, my buddy Nate here. Nate, thanks for tuning in. I love it. He's a huge serverless fan. Actually, completely sidetracked me. Thanks, Nate. Watching his team build out serverless stacks was really what inspired me to understand this well. I watched them move very fast and build some really, really cool stuff, and that I appreciate them pushing the bounds and pushing the edges, and I'm grateful for even working near them and absorbing some of that knowledge. There's a lot of edge cases, and I think they've pretty much found every single one of them. Anyway, so traffic patterns. Traffic patterns are not normally distributed across your app. You'll have peaks, you'll have valleys. So understanding, talking about it in much larger scopes of per day, per month, like those things are just, they don't help when you start designing for capacity. Really, like, serverless helps us avoid a lot of that concern. When you're in a serverless environment, really all you need to worry about is concurrency for the most part. How many things are happening at once. The billing pattern and the event-driven nature of it, you can absorb traffic spikes pretty solidly without having to worry about, do I have enough servers? Am I going to run out of memory? Like that stuff still matters, but with a distributed system like this, you get a lot more knobs to turn. You get a lot more places to tune and really understand how this thing could tip over. There's a lot of places in there where you can build it up. You can spread out capacity. You can funnel things back in if you don't want them to happen so fast. Like, there's a lot of things you can do. So concurrency is a far more important metric in my mind when I'm designing a serverless stack than how many X is it going to do within Y. Like, that doesn't matter. So this guy said about 6,000 messages per minute. Each message, the analysis of each message relies on the previous 200 messages. So for every message, maybe, if this is sensor data or something feeding in, the previous 200 events inform the analysis that's going to happen on this message. So right there, we know that we need to store at least 200 previous messages per ID. What else did he say? So we don't get data 24/7. We actually get data from during business hours. So we'll say, so from 9 a.m. to 4 p.m., real business hours. Yeah, the WebSocket didn't deliver outside of this window. So I don't know if it's just like, the hours that the building was open or something. I'm not sure. Like, we didn't get into the actual data or understand like what he's building here. But what that does inform is that we don't necessarily need this thing to be operating overnight. This thing, we don't need to have servers sitting there waiting for any messages, or we don't need to do any processing from maybe after 5 p.m. until 9 a.m. the next morning. For me, this is another big win of serverless because of that pay-per-use model. All you're going to be doing is paying for the data storage at rest. So you'll be paying for S3, you'll pay for DynamoDB storage, everything else, you won't see any costs outside of the processing window. So to me, just another win for like a serverless stack. Whatever we build to connect to that WebSocket and bring that data in, you can use some of the features of AWS to scale this up and down. So like, assuming we're going to go with a Fargate container, you can use application auto scaling and the timed scaling events in there to maybe scale this thing down after 4 o'clock. So now you're not even paying for that Fargate container. And then you schedule the scaling, spin back up in the morning. I think there was a concern of, oh yeah, let's put this into another requirement here. You could only have one thing connected to that WebSocket at a time. He was really concerned about duplicate messages coming in, so we want to make sure that we only have one of these containers up at any given time. There were, and we'll address like concurrent, or not concurrency, but replayed messages. So we'll make sure that there are chances that you can have multiple events fired inside your AWS account. You can have multiple deliveries of the same event when you start getting into queue. Well, not necessarily queues, but other triggers can have these kind of multiple invocation events. It's pretty rare, but it does happen. I know the team at AWS was working on solving that, making sure that those events are far more resilient and reliable. So I haven't been on a call with them in a really long time, so I have no idea where that is. But it was definitely something that they were working on. Let's see. So we need to keep the previous 200 messages, but we don't need to keep any more than that in the Dynamo table. So we can use that requirement to help design our data retention inside the table. Which you should, when you're building a Dynamo-based system, the cleanup of those records can be a real pain in the butt. So definitely think about retention right away. The auto deletion in a table is based on a timestamp, and if you're not writing that timestamp into your record from the get-go, you might not be able to actually clean that table up without spending a ton of money to walk through that table and write timestamps into existing records. So, this is definitely one thing that you want to design early on. Is like how long do you expect that data to last? It's less of an issue with S3 objects because you can S3 writes metadata with the object by default, and then later on you can go through and configure your retention periods. You can configure the policies on that bucket to help roll them into infrequent access or Glacier. There's a lot of S3 is super configurable in terms of trying to save money around access patterns and long-term storage. But there's some gotchas. You know, with this system that we're designing, each one of these objects is going to be small. You know, it's a few kilobyte record each one. When you start looking at moving things into Glacier, the size of the object actually matters in terms of the cost profile. Maybe I'll have to do a video on this because there's a few gotchas there, but I've seen, you know, people decide, well, you know, we don't access these things very often. They're small, so let's just turn on the auto send to Glacier function in S3. But because they were small and because of the way Glacier, the billing mechanisms in Glacier, it ended up costing them more money to move these things into Glacier than it did to just keep them on the disk in S3. Which, you know, just you expect, like, okay, I'm going to move this stuff to Glacier, I'm going to save some money, right? But then for it to turn around and cost you more because the objects are too small and they charge by a kind of a minimum size, it catches people by surprise sometimes. I think those are all the, so these are the requirements from, we'll call him the customer, friend of mine. So I think these things make the choice to go serverless pretty obvious. There's still some reasons why you may not want to. You know, you may not want to go serverless if your organization doesn't have much expertise in it, and you're not willing to risk learning it on this project. You know, if this thing is super business critical and you got a bunch of people who are really good at standing up, you know, pet servers and maintaining those and keeping those things running, you know, don't take the plunge on a new tech on a super critical service. Find something else to build that up, to build those skills up, or hire somebody in who can do it. But I think just the entire nature of this thing, for me, it's an obvious win to put this in a serverless stack. The requirement that I put on top of every project that I work on is I'm a cheap ass. You know, I've spent way too long managing large corporate AWS budget, and I don't want to spend a dime if my resources aren't actually doing anything. So again, serverless, you know, works really well for this. I really, you know, this requirement, this cost, you know, my frugal nature, as I'll describe it, it really pushes me away from a lot of technologies that people love using. I don't like any persistent EC2 instances or VMs or anything in an environment. It actually drives me crazy when I have to stand up a machine to do something when I know 80% of that machine's time is going to be spent idling with no human being looking at it, without any, you know, with that CPU sitting at 1% or lower. It drives me crazy to know that I'm paying for nothing. It bothers me so much. So, you know, I've not developed skills in things like Jenkins or you know, the more typical CI/CD products, because I don't like a lot of them just, you know, I don't like spinning up VMs in my environment and then watching them sit idle. So I've operated them in the past. I've done some configuration. Just not my favorite. I don't like that aspect of it. You know, if I could, I'm still waiting for GitLab or GitHub or one of these CI/CD, you know, providers to build something that's queue-based. So I would love to see kind of a really light front end, and then it builds some kind of message payload or package, and then that goes into a queue, and then I can auto scale my runners on the back end to actually consume that package, do the, you know, whatever tests or deploys or whatever it's going to do, and then feed that back to my UI. All right, so what did I miss here? Oh, WebSocket. Okay. What else did he have? He had a $2 sign budget. Definitely not $5. So we couldn't stand up a Kubernetes cluster and then, you know, pay a whole team to maintain that while the rest of our developers figure out how to consume and process these messages. So we're gonna go with restaurant pricing. I don't know, what else do we have for requirements? Let me see if I can find anything else that we might have missed here. In the consulting space, you might call these non-functional requirements. The term kind of drives me crazy because, like, everything's functional. You know, everything informs the architecture or the design. So I don't know why. I don't know why they call them non-functional. Maybe I'm just not around the consultants enough to understand that. Oh, he wanted to use Python. Yeah. Which was fine for me. I'm pretty comfortable working in Python. Lambda supports Python really well. Some of the frameworks and other things are support Python too, so it's a good language choice. Cold starts are pretty low on Python, so, you know, a well-written function with really small clients and everything to instantiate, you can get a pretty low cold start. If we're worried about that, we can do provisioned concurrency. I've been learning Golang lately, so I'm not sure if maybe I should write this in Go. I should say I've been relearning. I did a project a while back with a personal project where I wrote a bot for Twitch live streamers. So this thing would open up. Fun fact, Twitch chat is just IRC underneath the hood. So I wrote a bot that would connect to an IRC channel, handle all of the heartbeat messages and the acknowledgements and all of that, and then it could post and reply to comments and stuff in there. It was pretty cool. I don't think I have it on this machine anymore, but I really I went with Golang for that project because I really wanted to learn the Go pipelines. The message ingestion from a Twitch chat can be quite vigorous. You know, there can be a lot of messages coming in really fast. So, but a majority of those messages, I didn't want to respond to or reply to. So it was important for me to have a really, really fast front end, you know, really fast ingestion point into the system. 99% of those messages would get discarded, not acted upon. So I wanted to see how fast, you know, how Golang could architect around that. So that's why I dug into that, wrote it. Wasn't very good. I didn't do any formal learning. It was all just reading the docs and getting it working. I'm sure I made a lot of mistakes, which you should. If you're learning a language, if you're learning programming, you're going to make mistakes, and that's okay. The most important part is to learn from them, obviously. But then one of my current coworkers is going through a bunch of Udemy courses, and our team has been kicking around the idea of, you know, which language should we collectively rally around. Python was kind of the early obvious choice because most of us had, you know, if you averaged out our skill across the whole team, most of us, Python was a pretty solid choice. But I think as the I don't want to say DevOps profession, but like as these jobs in the DevOps space move, as they roll forward into the future, I think Golang is going to become one of the more important languages to learn. And it's usually when you see language, you know, debates or arguments, everyone wants to argue about you know, oh well, the ecosystem or the community, or, you know, they want to point at speed. You know, some people are really hung up on like how fast it is, or how fast can I develop, or, you know, does it come with a bunch of boilerplate, or, you know, whatever things they want to argue about. I try not to get caught up in those things because I think what matters more is the companies that are using it and the things that they're writing in it. So, you know, when you start looking at all of the HashiCorp products written in Golang, you know, I think HashiCorp is going to win for the next, you know, 5 to 10 years in the technology space. So I would say, you know, anything that they're using under the hood is probably a safe bet for you to develop as a skill. So that's why I think, you know, Golang is a good choice. And it's a good language. You know, you'll learn some really solid programming skills using it. It's not as fluid as Python, but you also, you know, you need to be more technically rigorous in Golang. You can't just, you know, pull in a string and use some JSON converter to turn it into a dictionary or anything. All right, we're coming up on an hour here. I do have to actually do real work today, so I think this is going to be good for now. Let's save this. Let's commit. Always commit your code. Always. Here we go. All right, so that was today's work. Committed, pushed. You'll see that I'm doing the very bad practice of committing straight to master. We should probably talk about that in the future. Why is that bad? Well, lots of reasons. But just a README update for now. Probably not that dangerous. Let's make sure that it is here. Bingo, bango. There we go. Got our non-NFRs. We've got our kind of early architecture. So I think on the next stream, we'll go through this architecture and probably diagram it. And then we'll start laying out the repo with the folders and structure that we need. I'm trying to do these more often, probably a few times a week. So if you're interested in watching this project develop, or if you're interested in hearing me interview some local recruiters about DevOps related jobs, you know, subscribe or follow me on various platforms. My Twitter handle was down here. I'm pretty active on Twitter. If you want to talk to me, that's where I'll be. Otherwise, I'm signing off for the day. If you have any comments or anything, leave them. I hope I'll address them. Thanks, everybody.